Hello everyone, I'm Dan. In this assembly language tutorial, I'm going to show you how to write to the screen, basically using system calls and system write specifically. To get started, let's go ahead and open up your web browser to my website, thegpu.com. We'll scroll down here to assembly language, and then we'll do writing to the screen. So this tutorial will introduce you to system calls, specifically the system write, syswrite call. In higher level programming languages, functions, methods, procedures, classes, etc. all have arguments and parameters that directly follow the name of the function, method, etc., etc. In assembly language, we place the system call number into a register, then we place the arguments and parameters into other registers. Now, once all of the move instructions have completed, then an interrupt call is executed to instruct the processor to actually perform the operation. This tutorial is going to focus only on NASM. The feedback that I've been getting so far is only interest for assembly and Linux, but nothing much for Windows, MASM. So please leave some feedback in YouTube comments one way or another. Okay, let's talk a little bit about syswrite. So the system write call number is base 10.4, or hex 4 or hex 4. All three of these you'll see it represented as all three in various code out there. Now, and I will move that number into the EAX register. Okay. Now, the terms standard output and standard input are used on a regular basis in the world of programming. Standard output is usually to the console, in other words, the screen. And standard input is usually from your keyboard. In this tutorial, I want to display the output to the screen, so I will set the standard output argument of 1 into the EBX register. Now, I need to let the syswrite call know what string constant that I want to display to the standard out. So I will place the name, and I'll show you in the code below, of the constant that I want to display into the ECX register. Okay, just going to go into this right here, right? Moving 4 into the EAX, moving 1 into the EBX, and I've got this string constant up here. I'm going to go over this here in a little second, called what to write, and I'm moving that into the ECX register. Okay. Now, what happens during this instruction is that the starting memory location of where the constant is located in memory will actually get placed into the ECX register. So I'm going to move the name of the string constant into the ECX register. Now, the last argument that I need to set is the length of the string constant that will be displayed to the standard output. The total length of the string constant in the ECX register should be moved into the EDX register. Now finally, I will call int Hex 80, which will instruct the processor to execute the call number contained in the EAX register. Let's talk a little bit about the interrupt 80. Interrupt 128, which is base 10, Hex 80, is the 32-bit syscall handler in the Linux kernel. Now int 80, Hex 80 always expects the EAX register to contain the system call number. That's important. Now, based on the system call number contained in EAX, arguments can be moved into EBX, ECX, EDX, ESI, and EDI registers. Now, I have not discussed the ESI and EDI registers yet. One thing to be aware of is that once a int28 syscall has been executed, result values may be stored into those registers. Like, for example, EAX will often have the result called move to it after a syscall is executed. And I'll go over that in the video here and show you some interesting stuff about that. So let's write some code and explore the resulting machine language. Okay? I'm just come down here and copy the code first. All right, and then let's pop over to my other screen. All right, let's open up terminal here in Ubuntu. Okay, so right off the bat, I am going to, and by the way, if you're kind of unfamiliar with what I'm doing right here, watch my tutorial on installing, NASM. Want to make sure you get that up and running first and foremost there. So I'm going to make a directory here called assembly, right? And I already have that folder, but If you don't, that'll create it for you. I'm going to go ahead and change directories to the assembly folder. And today, let's see, I'm going to make a directory here called syswrite underneath here. Okay, and let's go ahead and change directories to that systemwrite folder, syswrite folder, and I am going to leafpad. And in my tutorial there, I also show you how to install leafpad. It's just one of my favorite editors here for Ubuntu. And let's call this syswrite.asm. We need that ASM assembly language extension there. Okay. All right, let's go ahead and paste all this stuff in here. And we'll come up here and save this. So what we've got here is we've got this data section, and this .data section here is where all of your constants go. In my next tutorial, where I'll be talking about the system read stuff there, we're going to have a .bss section there, and I'll go into that, and that's where variables can be contained. But these are your constants, and the way this works is you've got your constant name, and then you got this db, which is short for defined bytes, and then you actually have your string, right? And then I'm tacking on a comma on the end of that, and then 10 is a line feed, and 0 is a null 0, right? This next line down here, len, that is a variable name, and then this EQU, that is an assembly language. No, anyway, it means equals. And then $sign means, well, you know, getting a little ahead of myself here. I haven't gone into necessarily the whole structure of all this, but it basically means where we're at in the program, minus the starting location of what to write will get stored into there, right? Basically, it gets stored into here, sorry. This will be the whole entire length of this string plus the line feed and the null 0. Same thing here, what to write to, len to. All right, so text section is where our executable stuff is actually going to be located. Global start. Okay, so the first thing I'm going to do is move EAX in, or 4 into the EAX register, 1, which is the standard output, in the EBX register, what to write, which is the name of this constant up here, into the ECX register. Now, this is kind of interesting. I'll go over a little bit about that when we open up the machine language and look at that there. And then length is the actual length up there. You know, we could have actually counted this all out. This is actually 40 bytes long. I could actually hard code, for example, like 40 in there, but I just want to show you guys a little better way of doing it than hard coding it. And then we call the interrupt 80, right? The system call. Okay. Same thing for the next line over here. And there is a purpose on why I've got this displayed twice. EAX 1 is the sysexit call, as you probably are familiar now. Now I could have moved into the EBX 0, but I wanted to introduce, you know, another one here, XOR. XOR, if you XOR EBX with what's currently in it against what's currently in it, it will actually do the same thing as moving 0 into EBX, but it actually does it faster. And I'll get to some of that in future tutorials there. And then, of course, we call the interrupt 80, the syscall. All right, let's go ahead and open up another terminal, and we'll go ahead and compile this, run it, and then we'll pull it apart, do the fun stuff on that. So let's change directories to the assembly, change directories to the system write. Let's go ahead and NASM, -f, elf, and hit tab there, compile that. -m, elf underscore E3I386, syswrite.o, and -o. And all this stuff is on my on my website there as far as these instruction goes, if you're not familiar with there. And that'll be the name of that. Let's go and do an ls, see what we got right there. There's our syswrite, and let's go ahead and call the syswrite. And there we go. Writing first message to the screen, line feed, right? Writing second message to the screen, and our visible line feeds are there. Okay, pretty cool. Straightforward there. Let's go ahead and crack open the Hex Editor here. And all this stuff I've covered in my previous videos there, but if you want to install the Hex Editor, I don't remember exactly which one that was in. Anyway, let's go ahead and crack open the Hex Editor here. And let's go ahead and open assembly syswrite, and there we go. Okay, now on my previous tutorial, basically, let's move this to the side and we'll kind of go through everything here. The EAX register, whenever you move something into it, it always starts out with a B8. So we're looking for a signature. It happens to be right here, right? So we're moving into the EAX register, which is the B8 opcode, right? And then 4 is the argument there. Now the next line into the EBX register right there, BB is that instruction, and 0, 1, which we're moving into there. Now here's where it kind of gets interesting, okay? On this B9 register, if we look at the disassembly over there, we've got ECX, and then we got this hex number here, right? I'm just going to kind of introduce you guys to a little bit of stuff here. So the ECX register, which is this instruction right over here, what to write, right? That's basically, it's going to be interesting. I'll get you started on this, and then in future tutorials, when I start talking a little bit more about memory and everything like that, this will make a lot more sense, but it's beyond the scope of this tutorial right now, but I'll show you something pretty cool here, right? So if we highlight this right here, right, all the way over to the null 0, right? This is writing the first message to the screen, and it's contained right here. Now, I wish the WX Hex Editor had a way to display the offset in hex instead of decimal, but that's fine. We'll just pull up a calculator and convert it here real quick. So this message starts right here at this byte, right? ASCII 57 is uppercase W. There is our line feed, and there's our null 0 ending that constant right there, okay? Now, that's contained at, this is 176, 77, 78, 79, 80, 81, 82, 83, 84. So 184 bytes into the actual machine language, the actual executable here is where that starts, okay? Now, let's grab that. I'm going to pull up, I've got kcalc on here. You can use really, almost most calculators will convert between decimal and hex. So we go 184, and then we click on hex over here. We got this B8, right? Okay, so what you'll notice here on this instruction here, which is the move ECX, what to write, the first B9 is the move ECX, right? And then you'll notice this first byte right after that happens to be a B8, which just happens to be where this starts out. Okay. Now coming down here, the next instruction, which is the BA, which is move into EDX, hex 28, right? If we convert hex 28 to decimal, right? Let's go ahead and hex 28, convert that to decimal. That's 40 in base 10. Okay. So this tells us that we're going to read 40 bytes, basically from the offset of where this memory is going to start here. And sure enough, if we look at this here, right, including the starting from right here, right, all including the null 0, we've got 2 lines of 16, 32, and then we've got 34, 36, 38, and 40. So that character, that constant there is actually 40 characters. So that's what's contained in that. Okay. So all pretty straightforward on that, and I've kind of lost track of where I was before there. B8, yep, there we go. Okay, so there's that instruction, that instruction, that instruction. There is that, and then CD, of course, is the opcode for the interrupt, and then 80 right there. So then, boom, that's when we display that line of code to the console there. Going into the next section down here, move EAX to this, right? So let's go to B804, BB01, which is the standard output. B9, right? This tells it to move ECX, the address of that there. Take a look at E0 here, right? Now we know the second message starts off right down here and goes all the way through that right there, basically, right? and that was E0. Let's go ahead and type in E0 on the hex and take a look at the decimal, and that would be 224 bytes into that, and as you can see, that's where it goes on there. In future tutorials, I'm going to describe what the other numbers do and everything like that, but don't worry about that for the time being there, okay? This one happens to be 29, one character longer than the other, and maybe it's 2 or 2, but anyway. And then our CD80 right there, which will display that to the console. Then we're going to move the sys exit right there, right, and back into B8. Well, there we go, right there, okay? Move EAX1, which is the sys exit routine, okay? And then 31 is the XOR routine, right? Or actually, 31 is the, well, anyway, I'll get into the XOR EBX a little bit later. I'm going to do a whole tutorial on that. It's kind of cool. But and then there's our CD80, which is our interrupt syscall 128 decimal, right? Okay. Now I want to go over a couple of things here. All right, let's just close out of that. What I'm going to do here is I'm going to comment out this line right here and this line right here, right? It might be an easy assumption to make that, you know, we've got 4 in EAX, we've got 1 in EBX, and then we move this value to ECX and EDX, and then we call the interrupt here, right? Now, we might say, oh, you know, hey, since I didn't change the value of EAX or EBX, right, then it'll still have those in there, and we still should be able to see the exact same output. And I'll show you that will not be the case. Okay, we only got the first, writing the first message to the screen. And that's because the EAX no longer contains 4 in there. It contains something completely different after the interrupt 80 call got made there. Okay, all right, now I'm going to put this back here real quick. And the next thing I'm going to show you here, and this is also pretty cool, a little pitfall to avoid there. Let's go ahead and recompile this. Run it just to show you we got it going good there. All right. You might be tempted to do something like this, right? Where you say, okay, I'm going to declare all my my constants up here, define my bytes, what to write and what to write to up here, and then I'm just going to set the link after that, right? And what we're going to get is some interesting output here, and then I'll explain to you why that is and why you have to kind of have a little different mindset with assembly on some of this stuff here. So let's go ahead and compile this. Then we'll go ahead and run it. Okay. Now, do you see how we got writing the first message to the screen, writing the second message to the screen, and writing the second message to the screen again? Well, that is because, let me show you, let's pull it back up the Hex Editor here. Okay. With this highlighted right here, what we did is we defined both of these bytes as constants in there, and of course the NASM put it in there, and they're right next to each other, like one finishes up and the next one starts, right? So right down here, when we use this EQU, and we're assigning it to the result of this to this variable length, this says where we're at in the program at this point in time. We want to subtract where what to write actually starts. So in other words, we're going to subtract here and go all the way to here, which happens to be not just 40, I think it's like 81 or 82, right? So it basically stores the length that we're going to print in this particular thing. Instead of 40, we've got like 81 or 82, right? The next line, so the print off over here on this, right? When we call this interrupt right here, this length is going to be 81, 82 or something like that. And so this is this instruction, right? This is the result of this instruction right here, writing this to the console there. So that's what's going on with there. Now, when we say len2 equals, and then whatever point we're at minus what to write to, it's basically coming back into here, and of course what to write to starts off right there, so we end up with the proper result for when it actually displays this to the console the second time. So hopefully that makes sense there. Just some things to be aware of, to be cautious of. So I think that'll probably do it for this tutorial. That's gone on for almost 20 minutes here. Anyway, I am going to pop back over to my other window here. Give me just a second. Okay, all the instructions here, what you need to compile, so on and so forth there. But anyway, pretty much just stay tuned for my next tutorial where I will introduce you into the system read stuff, which is interesting there too. We get to talk about actually creating variables versus constants. So anyway, that concludes this tutorial. Thanks for watching.